Hello and welcome. In this video, we are going to take a look at our P5 modified, and specifically, we are going to focus on the version dealing with the geometric properties of certain cross-sectional areas. Now, this video assumes a number of things, primarily that you have completed your original P5. We're not going to be starting this project completely from scratch. Instead, what we're going to do is we're actually going to leverage the P5 that we did earlier in this series that again focused on the geometric properties of certain cross-sectional areas. The other thing I'm going to do in this video is I'm going to talk a little bit about this nested structure that we are using. One of the advantages of it, hopefully you will see when we get done, is going to be the number of arguments being passed to each one of the functions. In addition to that, I'm also going to talk a little bit about passing a structure by reference or by address, and a little minor syntax difference then that is needed to be able to access the elements of the structure inside of the functions. Now, to begin with, I want you to grab a copy of your P5 modified instructions, also the P5 modified setup, and then go ahead and find your P5 project itself so that we can go ahead and borrow very heavily from the code that you've already written. As a matter of fact, you're going to discover that to some extent, this project involves a lot of copying and pasting if you've done your P5 correctly. And so let's go ahead and get started. We'll take a quick look. You'll notice here that in my P5 modified setup, all I've done basically is I've went ahead and copied over the constants, the structures, as well as the function prototypes, and I've went ahead and set up our main. So let's take a second to focus real quick on one of the structures. Again, in this video, I'm going to focus solely on the first function that is going to handle our circle properties. And so you'll notice here that I have a circle 2D results structure. And some of the properties that are associated with this structure are essentially very similar to the ones that you would have found in your P5. Now, the difference being is in your original P5 in these functions, we had to pass all of these arguments individually, whereas if you scroll down and you take a look at the function prototypes in this example, we essentially pass an entire structure. If you want to sort of think of this as a toolbox or a crafts box or a box that has a bunch of compartments in them of various sizes, but well structured, essentially that's what a structure is. It's an allocation of memory that is structured for different fields, and those fields can have different data types. And what we're going to see in this example is that those individual fields can themselves be structures. And so right off the bat, the first thing that you should notice is the number of arguments dropped significantly. As a matter of fact, we're only going to pass one argument for each one of our functions. And so you can immediately see one of the advantages of using a structure is that your code is a lot cleaner. There is, however, another significant advantage, and that is that if I choose to add additional fields to a structure, my function prototype does not change. Now, obviously, we would have to write code inside of these functions that would leverage those additional fields, but the function prototype itself does not change. What I want you to do is briefly think about this with respect to your original P5. In other words, if we added another argument that we wish to pass to our function, you would have to make the change not only in the prototype, but also down in the code where you have written the function. Translation, it gets pretty inconvenient to make changes in code that needs to be long-term sustainable. And you'll also notice that as we saw in our P5, specifically rather in the rectangle hollow 2D example, the number of arguments got painfully long, whereas we can simply just stack them inside of our structure and accomplish the same thing and pass a single variable. Now, the other thing before we leave this, before we get started coding, that I want to focus on is the fact that in addition to an integer and 3 doubles, specifically 2 double single values and then a double vector, we are also storing another structure inside of our circle 2D results. And the idea here is twofold. Number one, I want you to get comfortable with the idea of having nested structures. In other words, that you can have some properties associated with, in this case, the 2D results, but you can also share those properties with the annulus and the other results structures. But the second thing that I want you to look at then is notice that each of the fields inside of your calculated properties are essentially the vectors that you calculated in your earlier P5. Those were those parallel vectors. And so essentially what we're doing here is we are passing a structure, or rather a nested structure, and in that nested structure are the parallel arrays that we updated in our earlier P5. Now, hopefully this will start making a little more sense to you. It's just, again, a nice, cleaner way of passing the values, or in this case, passing the memory address to a structure to our function and then updating that structure inside of our function. So let's go ahead and get started. And again, I said we're going to be borrowing very heavily from our original P5. So if anything, you want to be prepared to do a lot of copying and pasting in this particular example. And we're going to start off with what I like to think of as the core variables that you pretty much need in almost every application. And that is going to be some way to iterate through your arguments that are being passed on the command line, as well as capture the results from any functions that are being called. So right off the bat, let's go ahead and copy and paste some of that code over. We can go ahead and initialize our results equal to 0 or equal to exit success, whichever you would like to initialize them to. And then we can go ahead and, again, put this little convenience for loop in that allows for us to enumerate through each of our arguments that are passed on the command line. Now, you'll also notice here from our earlier example that we had our radius max and our radius min, as well as our n. Now, I'm going to talk briefly about this. We are going to use these initially, but then I'm going to show you how you can get away from using these in their entirety. And so essentially what I'm going to call these for right now are convenience variables. And hopefully when we get done with this, you'll see why they are, in fact, convenience variables. All right, and then again, what we probably want to do is initialize those to default values. Again, good habit to get into, even though we may be assigning those values later on in the code. Probably not a bad idea to just simply initialize all of your variables. That way you're guaranteed some known value in them. Now, we're going to go back over here. And again, as I said, the differences between your P5 and your P5 modified from a user perspective are actually minimal. In this case, basically the switches that are passed on the command line are identical between the two versions of the application. You can think then of these result structures are actually helping the developer more than they are actually helping the user of your application. And as such, it means that this if structure that we use to triage our command line arguments does in fact not change. And so what you want to do is you can go ahead and very carefully, almost surgically, if you would, remove out the portions of the if structure that we need that essentially triage our command line switches. Again, as I mentioned earlier, we are going to be doing a lot of copying and pasting in this video, really to help you appreciate how similar these two applications are. And so you'll notice here that I'm, again, just very carefully reaching in and I'm grabbing the triage arguments, or excuse me, the triage else if structure that handles my argv's and my argc's. And then, of course, down here at the bottom, you want to go ahead and make sure and close out that if structure with the appropriate else. And again, make that implicit call for help. Now, before you go any further, you want to do two things. Is number one, you want to make sure that you've got your code nicely structured. In other words, you can see here how I've maintained this nesting of my curly braces. That is partially for convenience, but it also helps you to determine if you've got maybe mismatched curly braces, a missing semicolon, or even a missing parentheses in your code. And at this point, let's go ahead and build it to make sure that we don't have any preliminary mistakes. Now, the next thing that we want to do is we want to think of the differences now between these two applications. Now, we said earlier that we are using our P5 that leveraged our by value passing of the radius max, the radius min, and then we pass these parallel arrays as well as our int n. And we don't really have that option in this version of the application. As a matter of fact, if you come over here to your prototypes, you'll see again that you only pass one argument. So effectively, what we have to do is figure out how to put all of those values inside of this structure. And what we're going to do is we're going to begin with those base values. And what do I mean? Well, I mean essentially this outer part of the structure, not the nested part, essentially holds those initial values. And specifically for the Circle 2D results, it's the radius min, the radius max, and then ultimately we are going to calculate the entire range of radii. Now, you'll notice that I've already created some local variables in main that match those names, but yet I can still have them as fields inside my structure. Again, that's okay because they don't really see each other, and so you can have those duplicate names. The fields inside of the structure can, for instance, match other variable names. However, we will need to create a variable to hold the entire structure. And again, there's some options available to us. We've already consumed or used our results variable, so we'll have to come up with something perhaps a little more creative. And in this case, what I'm going to do is I'm actually going to leverage this structure name. And again, some of these variables will probably get longer than what you will use in a professional environment. But to start off with, to really emphasize what we're doing here, I'm going to leverage then the structure name, and I'm going to create then a variable of type Circle 2D results. And to emphasize what this is, I'm going to simply call it example Circle 2D results. And now what we have done is we've allocated memory associated with this structure. Now keep in mind, that does not mean that any of the values inside that structure have been initialized. So at this point, what we want to do is start populating the fields inside of our example Circle 2D results. And what we can do here is we can again come back to our original P5, and we can leverage some of the tricks that we did in our original P5 to accomplish the same thing. Now, I'm going to do something a little strange in this video. I'm actually going to copy and paste the code. Notice which branch I'm in here. I'm in my Circle /interactive or /I. So I want to be in the same portion inside of our P5 modified. But what I'm going to do that's going to be a little strange is I'm actually not going to make any changes to the code. I'm going to leave it alone for right now. And what I'm going to do is I'm going to below this add then the new code. Now I'm going to come back in just a second and show you why we don't have to do it this way and hopefully not confuse you, but you'll see that we actually don't need the radius max, radius min, and n. And what I mean by that is we can go ahead and start with our example Circle 2D results, and then we can simply set a value or field rather in the structure to the value that we've just collected from the user. So in this case, then we will say example Circle 2D results dot will allow for us to access a specific element. And in this case, we're looking at our radius max, and that will simply be equal to whatever value was captured by our scanf and stored in our radius max. Now, as it turns out, we don't actually have to do this as a two-step process. What we can do instead is we can use the original scanf, and instead of trying to store it in the radius max variable, we can actually store it at the address of our example Circle 2D results dot radius max. And now hopefully you can see why our radius max, our radius min, and our n are in fact nothing more than convenience variables. Now, I really don't mind which way you go about doing this. You are technically using a little bit more memory here because you've allocated these convenience variables. But in the grand scheme of things, if it helps you understand your executable or your application a little better, the code associated with it, that's perfectly fine. And especially if it enhances the readability of your code. For the purposes of this video, though, what I'm going to do is I'm going to pick one approach or the other. And since I am going to try to show you how to use structures here, what I'm going to do is I'm going to get away from this two-step approach, And I'm simply going to go ahead and plug that value for radius max directly into the address or the location inside the structure. And so you can essentially think of it like you know where in your tackle box or in your crafts box a particular item goes. And essentially, in this case, you simply insert then the radius max into that location. Now, we're going to do the same thing with radius min. And again, what I'm going to do that's going to be a little bit strange is I'm actually going to leave my original code in here in a comment. And what I'm going to do is I'm simply going to do a little bit of careful copying and pasting here, leveraging then the address of the example circle 2D results instead of the address of the individual variables. And again, you can see here with that dot notation, it simply allows for me to access then the individual values or the individual fields in my structure. Now, again, we're going to do this for our n. And again, we are simply going to replace the address of n with the address of the structure and specifically the field in the structure that corresponds to our n. And at this point, you could argue that you can simply go ahead and comment out these variables. And again, I'm not going to encourage necessarily or discourage you from doing one approach or the other. Use whichever one makes the most sense to you. But in this case, you can see here that we technically don't need those three variables. At this point, you are now ready to go ahead and call your circle 2D v4. And much like before, we're going to capture the results in our results variable. And so we'll go ahead and call our circle 2D v4 modified, and we are going to pass to it our results structure. In this case, it's going to be the example circle 2D results. But the thing to notice here is we want to pass the address of that structure. Why? Well, because we want to make updates to that structure inside of our function. So again, much like in other functions we've seen, we want to pass the address of the variable. And in this case, it's our example circle 2D results. Now, at this point, we can once again go back to our P5, and we can see here that some of our logic is actually going to be the same. In other words, we need to make sure that our function has successfully returned. And in this case, then we simply want to throw in a if followed by an else. And then in the else branch, then we simply want to print some sort of error, in this case, failed to calculate the values. And again, whatever comment you want to give to the user, whatever would be helpful is up to you. Now, what we want to do is we want to briefly jump now from our main into our function. And so we want to do this both with our original P5 and then also in our P5 modified. And so what we want to do is we want to think about now the differences between these two functions. As it turns out, much like in our main, it becomes somewhat of an exercise in copy and paste. Now, before I do that, I want us to think real quickly about what our result structure looks like. And as hard as this is to describe, I want us to think about the structure of it. And so once again, let's go up to the top. We'll look at the structure and remember that in the base of the structure, we have our n, our radius min, our radius max, and then the radii vector that represents all of the calculated radii from the min to the max. And then we have this nested structure that are the properties that we wish to calculate for that specific cross-section. So again, just make a quick mental note to yourself what the structure of this structure looks like, so that then when we come down here into our circle 2D v4 modified, we know how to access it. And so I'm going to take just a second before we get started to look at this. So I'm going to start off with our results struct. And this is where it gets a little strange, or rather the syntax gets a little strange. Earlier, outside of our function, we simply use the dot notation to access an individual element in the structure. Well, you'll notice here that NetBeans immediately changed this over to a dash and then a greater than sign. And you're probably wondering, well, why did it do that? Well, you got to remember that outside in our main, we were dealing with the variable itself. In other words, we were dealing with the structure directly. However, inside of the function here in our v4 modified, we are passing the address of the structure. And remember, the address of the structure just simply tells you where in memory it is. And this dash greater than sign essentially dereferences the memory so that you can so that you can access the value that is stored at that location. And so you can think of this somewhat as the relationship between the ampersand and the asterisk when you dereferenced an individual variable in our earlier P5. Now, at this point, then, you can see here that our results struct dash and then the greater than sign n simply allows for us to access the n, or the number of values. Now, I'm just going to make this as some notes here so we can appreciate what's going on before we actually get started. I can do the same thing, as you can imagine, with our radius max as well as our radius min. And so we'll do, again, one more. But what I want to do is I want to take just a second to focus in on how we would access the additional properties. And so we can again start off with our results struct. And again, we would start off with that dot notation, but again, NetBeans helps us and corrects us quickly. We can also go ahead and do this manually ourselves. But you'll notice now that I have my entire properties structure, that nested structure, which then allows for me to access the additional fields IX, IY, and IZ, as well as the area and the edge. So now that we sort of understand how we're going to access the individual elements in the structure, what we want to do now is we want to go back to our P5 and we want to see how we can leverage our original P5. Well, it turns out that we're still going to need some of these local variables, and specifically the radius delta and the radius current. In an earlier video, I explained why those are also somewhat of a set of convenience variables. We also want to go ahead and throw in our printf because it essentially allows for us to check to make sure that we've wired our functions up correctly. Matter of fact, take a second to go ahead and change it to our v4 modified just so that you can troubleshoot better. And then what we want to do is piecewise bring over our validation of our input arguments. Now, what I'm going to do is I'm going to go ahead and make, I guess you could argue, quite a big mess of things by simply going in, copying and pasting my entire if structure over. As it turns out, we are going to use it almost in the exact same fashion, but making some changes to access the individual elements in our structure. And again, as you can see, we now have code that absolutely will not compile. As a matter of fact, you can try it and you'll get all sorts of errors mentioning variables that have not been declared. But recall now that we actually have the radius max, the radius min, and the n are all buried inside of the results struct. And then the radii, edge, area, IX, IY, and IZ parallel vectors are all stored inside of that property struct that sits inside of our results struct. So really, at this point, it's just a matter of very carefully, again, almost surgically going in and making some changes, because functionally, this code is no different than our earlier P5. And so we'll go through using this little cheat sheet, if you would, that I've created up here. And you'll see that if I want to access n, well, I simply need to prefix it with the address of the results struct dereferenced to the particular field for n. And so we're going to jump down here. We'll do our n's first. If it makes you more comfortable, I would encourage you to go ahead and use an extra set of parentheses around this. They are not necessary, because if you take a look at the order of operations in the C programming language, a dereference takes precedence over a greater than or less than or equal sign. So this, again, is just somewhat of a convenience here, helps you read what's actually going on. But what we're doing here is much like in the earlier P5, we are simply comparing to see what the value of n is and making sure that it is 2 or more, and not greater than our n max. And again, I talk a little bit about this negative logic in the earlier videos, so we won't spend too much time on our if structure here. I'm going to do the same thing with the radius max and the radius min. And again, I'm going to use my little cheat sheet up here that we created earlier. And I am going to go ahead and use an abundance of parentheses, arguably too many. But hopefully these will be beneficial to you. And basically everywhere that you are trying to access the individual fields, you simply have to prefix it with the variable that holds the address of the structure. And so again, you could probably now see why I call this a little bit of a copy and paste exercise. Again, this line is probably getting a little bit long here. And so at this point, we probably want to consider breaking this up, but we can do the same thing now with all of the locations for both our radius max and our radius min. And then of course, also for our n. Now, as you're following along here, before we get too far into this, I would encourage you to make sure you understand what you're actually doing here. In other words, we are essentially reaching into the structure and either assigning or pulling out values in the structure as opposed to those individual variables that were passed in the earlier P5. Now, keeping up with this, we've got a few more. We've got our results struct again for our n. We want to do the same thing for our radius min, which allows for us to calculate the current radius based on the number of iterations of our loop times then the radius delta. Again, none of the logic changes here, but what we can do now is we can look at those nested properties, the properties that are now in the structure associated with the properties. And again, take a second to make sure you really appreciate what's going on here in that we have a structure inside of a structure. Now, when I first did our little cheat sheet up here, I didn't emphasize one particular aspect. I wanted us to get started with this and then go back to this. I want you to think about this for just a second, the difference in the notation between how I access the outer part of the structure, in other words, the n and the radius min, versus how I access the properties in the fields associated with the properties. Well, again, if you think about this in the context of addressing, it kind of makes sense. Specifically, if you think about this operation right here, this dereferencing operation is only needing to be done once. In other words, if I'm trying to dereference a value from an address, I don't need to do it twice. In other words, basically, I know what the value of the property structure is once I know where it sits in the results structure. And at this point, then, every other field in the properties then can be accessed with the dot notation. Now, it turns out there's a couple of different ways that we can go about doing this, but let's stick with this notation in this particular example. And so you'll notice here that to access an individual field in the base structure, in other words, in that result structure, including that nested structure, I dereference the location to get the value. And then from there, I can simply reach in and access each of the individual fields in our properties structure. Well, what that means is that, again, a very careful copy and paste. In this case, we're going to reach in and just simply update then our edge, our area, our results, our IY, IX, IY, and IZ. Now we want to come back real quick to the radii because I did jump over this one because I want us to think again about what we're doing. We didn't mention it in our earlier cheat sheet, but in this case, then what we're doing here is we're actually accessing the vector in the base structure. So in this case, again, just so that we can see how this works, we can do our results struct. And if we do the dot notation, you'll see there is our radii. And then you'll see here again, NetBeans immediately switches over for us. And we can access the individual elements in that radii vector And what we want to do is we want to store our radius current in it. Now, if you recall from when we did this in our P5, you'll probably now agree that this radius current convenient variable is, in fact, awfully convenient, because you could only imagine what it would be like to try to keep track of this entire field inside the base structure everywhere you have the radius current. In other words, basically what I have highlighted in this dark gray would need to be copied and pasted into each one of the functions, making your code kind of unreasonably long, or at least unnecessarily long. And so this is sort of a true definition, if you would, of a convenience variable. Yes, it takes up a little bit of memory. Yes, it does require technically one additional operation, but it would be very beneficial to have. Now, let's go ahead and look back at our main. Probably a good time to go ahead and build, just to make sure that we don't have any errors so far. And now let's get to actually calling and then handling our successful results. And so again, what we want to do is we want to go back to our main. And what we're going to do is we're going to focus in on our /i. And you'll notice here that I have this printf vector double. Now, we did this two different ways in the early P5 videos. I made this a bonus, if you would. So what we want to do is we want to remind ourselves there's technically two ways that we can go about printing this table. And if you were not comfortable with this printf vector double function, little helper function that we wrote, we can essentially leverage the exact same code, except longer, in the parametric version, or the parametric switch of our else if. Now, what we are doing here is we are simply printing out the field and then following up with each one of the values for the radii, for the edge, for the area, for ix, iy, and iz. Now, what I'm going to do is I'm going to do one of these manually so that you can really appreciate what's going on. And then from there, I'm going to go ahead and get back to our copying and pasting, because hopefully if you see it once, it will make sense to you. So to begin with, I'm just going to go ahead and make this table here, the start of this table, and the border for the table. And in this case, I am just going to go ahead and copy over that header, if you would. And you'll notice here that I am going from index equals to 0 up to n minus 1. Now, it turns out that we chose not to use our n's. As a matter of fact, it'll probably be a good idea for us to go ahead and comment these out at this point, because we're going to get an error now, or at least a warning that we have a variable that we have not yet declared. Just to show that, let's go ahead and build it. And you'll see here that basically it's complaining that we're trying to use an n that we have in fact not declared. Now, that's not a problem, because as you know, or figured out already, we have our n stored in our example circle 2D results. And so essentially the only difference that needs to be made now is to access, again, that particular field or element in that structure. And how do we do that? Well, we simply specify our example circle 2D results dot n, and that gives us access to that individual field in the structure that has stored n, or the number of elements that we wish to calculate. And so at this point then, we just have to very carefully go in with each one of our fields. I'm going to do it one more time with the radius, just so that you can see. And so again, you want to think about now this radii that in our earlier P5 was a standalone variable, is in fact now nested inside of the structure. And again, all we have to do is prefix everywhere that we would have otherwise used that base variable, or that individual variable, including our n's. We simply prefix it with the structure name. Now, at this point, you probably are saying, well, that example circle 2D results is an absolutely terrible variable name because it is very long. And I would actually somewhat agree with you. However, though, it is very descriptive. And I just noticed I missed one more here. And so at this point, you'll see that basically everywhere that in the original example, or rather in our P5, that we used the variable by itself, we simply prefix it with the structure name because it sits inside that structure. At this point, then, basically, we can go through and do all of our properties this way, just being, again, very careful. Now, with our edge, our area, our IX, IY, and IZ, it does get slightly more complicated. And what I mean by that is, if you remember, those particular fields do not sit in the base structure. So what we're going to need to do is we're actually going to need to access not only the base structure, so we'll start off with our example circle 2D results, but we want to use the dot notation to dig into the property structure and then the edge field in the properties structure. So again, effectively, it's the exact same thing that we did in our earlier P5. The difference being is our data is just a little more structured. And again, everywhere where you have your N, you simply prefix that with the base structure. So at this point, it should probably become more clear that this is somewhat of a copy and paste exercise, or at least a modification of your variables, but with no real change in the logic. And so you could see here that I'm now at this point simply very carefully going in and copying and pasting. As a matter of fact, I'm going to speed this up now, in that everywhere I have my base N like this, I'm just simply going to go ahead and sneak in the structure name as well as the dot. And at this point then, for all of the N's, we simply just need to be careful and make sure that we get all of them. And then again, for those nested fields, the area, the IX, the IY, and the IZ, we simply need to remember that we need to access the property structure that is buried inside of that base structure. And again, just a little bit of an exercise in copy and paste. And hopefully this isn't going too fast, but you can see here that NetBeans is actually helping me by suggesting what fields I want to access. Now, fortunately, since we're modifying some code here, this is going to go pretty quickly. And then we'll see if we've got any more references here that we need to change. I have one more N up there. At this point, let's go ahead and build it. Let's see if we have anything left to do. And the answer is we don't. And we can go ahead and test this now by coming to our command window. We can go ahead and run our P5 modified, our circle interactive, and I'm just going to put in a value for our radius max of 2, our radius min of 1, and then I'm going to look for 4 values here, and you'll see that I'm going from 2, 1.667, 1.33, and down to 1, and then I have my edge, my area, my IX, my IY, and IZ. I encourage you to check these values right here, but the easiest one for us to check is the radius of 1, and the edge should be equal to 2 pi, and the area should be equal to pi r squared. So at least it looks like we are on the right track and we don't have any typos in our formula. Now we have one last thing that we want to cover in this particular example, and that is how to modify then our output. And what we'll do here is, again, we'll borrow some code from our P5. I'm not going to go into as much depth in this as I did in the earlier video. I encourage you to go back and make sure that you understand how this works. But I do want to focus on the overall recipe here, if you would, for our file output. And if you'll notice here, I need to declare a file pointer. And so one of the additional variables that we're going to need up here is going to be a output file pointer. And then at this point, then again, it's just going to be very carefully, almost surgically going in and changing how we access each one of these fields. Now, before we do that, I want us to refresh our memory real quick on the process here. The first step is, of course, to use our fopen to open the file. We're trying to write the file. A little minor thing for this project is it is going to be a Circle 2D v4 modified.csv. If we fail to open the file, we would get an output file pointer equal to null, in which case we would need to notify the user that there was a problem. Otherwise, we simply start printing. Now, I am going to switch notations on us here, so I'm going to go ahead and comment this out. And the only reason I'm going to do that is because I feel that it's probably going to be easier for us to see if we do this on separate lines. And so what I'm going to do now is I'm essentially going to rewrite my fprintf, writing to that output file. I'm not going to change this too terribly much here. I'm still going to keep my %8.4f or %0.4f that we used earlier, followed by the comma. But the difference is what I'm going to do is I'm going to do each of the fields individually. And so what we'll do here is I'm going to go ahead and make a copy of this particular line, so it's going to be pretty similar among all of them. But I'm going to then reach into our example Circle 2D results. And remember now that the radii, they sit at the base or in that base structure. And so we can access it directly using the example Circle 2D results dot radii. We then want to do the same thing for our example Circle 2D results. My autocomplete here failed me. But this time around, remember that we have to dig into the properties if we wish to get the edge. And again, we're going to access the individual element in the edge vector using the square brackets index. Now I'm going to do this one more time, but I think at this point, you're probably going to have gotten the pattern already. And so we have, again, we have our example Circle 2D results. In this case, since our areas sit inside of the properties structure, then we simply have this nested approach here, this dot approach. And again, now we're going to do the same thing for our properties associated with our IX. And again, you can see here as I'm still using the same parallel arrays from P5. They are just structured differently. They're nested inside of this structure. And at this point, then it's just our IY and our IZ. And then the only change that we have to make as far as our for loop goes, because we again did not use a local N or a N in main, we simply need to specify that it is our example Circle 2D dot N. And so again, what we're going to do is we're simply going to reference the N inside of the structure, which brings us back to one last point. If you decide to keep these local variables, in other words, if you decide that these are better for you in understanding how this works, well, the only downside to that is that you need to then make sure and keep track of any changes that are made in two places, because effectively you're going to have a local copy of that variable, the radius min, radius max, and n, but then you're also going to need to store a copy of it inside the struct. And so again, it's not impossible to do that. It's perfectly fine, but you'll just need to make sure and keep those values synchronized if they were to change via, for instance, user input. Now, at this point, let's go ahead and build it. And let's go back to our console one more time and just show you that I don't have any tricks up my sleeve. I'm going to go ahead and look here. I only have my P5 modified.exe. I'm going to go ahead and call my circle/I. I have a radius max of 2, radius min of 1, number of values 4. And now if I do a dir, there's my Circle 2D v4 modified. And I believe I have one mistake. Even without looking at it, I believe I did forget to do one thing. And that is, I do not believe I put, yes, I do have a problem here. Let's go back real quick. and figure out with our P5 modified. So I have the table is correct. There we go. Yes, I just realized I had a little typo here. If you were following along with me, you were probably yelling at the screen. And we'll follow up with a new line here. Let's build it. And then let's run it one more time. So 2, 1, and then 4. And then you can see there's our CSV file. Again, we can discuss the format as far as whether we include any spaces up front or not. That's the difference then between the %8.4f and the %0.4f. At this point, really the only difference between the two is much like in our P5, how we collect the values. So let's take just a second to see how that is done differently in the parametric version. And if you want a little bit of a reminder, you can go back to your P5. But effectively, what we do differently is we assign then the values directly into the structure using the A to F or A to I functions. Now, again, we talked about this before. We would need to do some additional validation on this. But since that's not the focus of this particular video, let's go ahead and set this up without validation outside in main. And so we simply then say our radius max or the field associated with a structure for radius max is equal to our A to F of our argv square brackets 3. Remember, that comes from the order in which we put the arguments in on the command line. It's technically now the 4th argument if you include the name of the executable. And we do the same thing for our radius min, with it, of course, being the 5th argument, or argv square brackets 4. And then the last one is going to be the n, which is going to simply leverage the A to I function on our argv square brackets 5, or the 6th argument. Now, at this point, then the code is essentially the same. So as a matter of fact, what you can do is very carefully go up here and do a little bit of copying and pasting, making a call to your circled 2D v4 modified after capturing the values on the command line. And we can go ahead and save it. I think I might have missed a parentheses here. Let's undo this real quick. I think I may not have, in fact, been careful enough. Let's go back here one more time. I want to capture here, and I think I missed one set of parentheses here. No, actually, I see what the problem is. I accidentally miscopied here. All right, give me 1 second. I've got to move a little bit of my code here. This portion right here belongs down further. This might turn into an exercise in matching parentheses here. Let's make sure that we don't even get ourselves straightened out here. All right, so there's our parametric example. All right, once again, what I'm going to do, let me go ahead and build it real quick. And let's see if we can figure out where the problem is. Yes, I have a mismatched parentheses here. So once again, let me pull this back out one last time. And let me build it just to verify that we have this working. And let me go up here real quick. So there's our if statement. There's our check. Yes, there we go. I'm not coming down quite far enough. And there we go. Now let's go ahead and build it. And now both our interactive as well as our parametric mode should now work. So let's test it with a different set of values. How about if we go from 3 down to 0.5, and let's look for an n equals to 6. Our table on the console gets bigger, and it also appears as if our table in our CSV file gets bigger. So I know this video was a little long. I tried to go into as much depth as possible and also explain as much as I can as far as the advantages of using a structure. So there's a lot in this video. The only thing that I did not cover in this particular video, again, is the use of this little print vector double function. Would encourage you to go back and take a look at it if you wish to do the bonus for the P5. And you could see that we could actually sizably shrink the amount of code in our P5 modified as well. But again, that part is technically optional. So as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.